In this video, we're going to have a look at stack buffer overflows. In previous videos, we talked briefly about what a stack buffer overflow was. So in this video, we're going to drill down a little bit. And one of the things that you really need to understand if you're going to understand stack buffer overflows is what we call a calling convention. Now, a calling convention is how we pass parameters to any functions that we call. Now, when it comes to 32-bit windows, there are three basic possibilities. One of them is called cdecl, the other one is called standard decl, and there's another one that's not as common that we'll talk about as well, and this one is called fast call. So what do these look like? cdecl is a calling convention where all of the arguments are passed on the stack. Now, the caller must clean up the stack when you use cdecl, and the arguments are pushed onto the stack from right to left. Now, this is a required calling convention in certain cases, most notably whenever you have a variable number of arguments on the stack. This is the method that you must use. And the reason for this is pretty simple. If you are putting a variable number of arguments on the stack, the function that you're calling has no idea how much space to free when the function is done. So in that case, you must use cdecl. Another option is standard call. So standard call is if you're using 32-bit Windows and the 32-bit API, Win32 as it's sometimes called. This is the standard call interface. All of the arguments are passed on the stack. Now, here's the difference. The callee cleans up the stack. Not whoever called the function, but the function that is being called is responsible for cleaning up the stack. Now, this has a nice advantage in that you have more condensed code because instead of having everyone that's calling a specific function having to clean up the stack afterward, all of that code is concentrated into one place. Now, you cannot do certain things with this method. You cannot call a method with variable arguments, such as printf and similar functions, using standard call. You're stuck with cdecl in that case. Now, just as with cdecl, parameters are pushed on the stack from right to left. The other option is called fast call, where the first two arguments are passed in the ECX and EDX registers, and the remaining arguments are pushed on the stack right to left. Now, the callee cleans up the stack if needed. And I say if needed because if there are only one or two parameters, then there is no stack to clean up. Everything is done completely within the registers. This is not a terribly common calling convention for Win32, but it is a possible calling convention. Let's talk about a successful buffer overflow exploit. What does that look like? What you have to do is overwrite the return address for a function and also inject some shellcode. Shellcode is some nice malicious code that you might have developed or gotten from somebody else. So shellcode is machine code that is easily executed for some purpose. And what you want to do in many cases is to copy this shellcode into your overflowed area and then just run it. We're just going to download our shellcode. A great place to go is shellstorm.org. So that's what we're going to do. When we get into the later stages of this course where we talk about exploit development, we will get into how you might do that yourself. Central to all of this is the stack. And being able to influence the stack and understanding how the stack works is the most important thing in order to write exploits that exploit stack buffer overflows. So the goal is to overwrite the return address and what comes after it typically This is accomplished by overflowing local variables. And by the way, for Intel, the stack grows toward lower memory addresses. We'll see more of this in some future videos. After the local variables, there is something called a frame pointer. Normally, this is related to the EBP register. The stuff you see in red is the return address, then it's some other information. So the goal is I want to overwrite the stuff in red. I want to change the return address so that it points at the space immediately following. And what I'm going to do is I'm going to overflow one of these variables here until it goes through this frame pointer, sets the return address to a specific value, and then that specific value will be the address immediately following, and that is where I'm going to inject my shellcode.